Hello, and today I'm going to present to you Pills Pain Relievers pH, effective GI pH on OTC pain medicine absorption. Do OTC painkillers cause more harm than good? Well, according to the Institute of Medicine, about 33% of Americans experience chronic pain, and 1 in every 4 of those Americans take pain reliever pills in order to reduce that pain. NSAIDs may have detrimental effects on the GI tract, according to the Johns Hopkins Institute of Medicine. So, if this is true, it is essential to understand the effects of these OTC pain relievers on humans. The approach of this experiment was to understand the solubility of OTC pain relievers in different parts of the gastrointestinal tract. The significance of this experiment was to better understand the side effects of these medicines and accordingly take appropriate steps to reduce the damage, from simple indigestion to stomach ulcers. The question of my experiment was, how does the gastrointestinal pH affect the absorption of over-the-counter pain reliever pills? Well, I hypothesized that if pain reliever medicines are soluble in different parts of the GI tract, then the dissolution of the OTC painkillers and chemicals that are compositionally alkaline fluids will take less time, while the compositionally stronger fluids with a more acidic pH will take more amount of time to dissolve the painkillers in the chemical. So the methodology I used for this experiment was first to wear safety garments and experiment under designated supervisor, pour 10 ml of my solutions in a separate beaker, and heat both chemicals. Take out the OTC painkillers and cut them into appropriate portions of 50 milligrams, and then test the before pH of all my solutions. After this, I checked the pH of the dissolved solution in 10-minute intervals using pH strips, and I repeated all of these previous steps for all of my different OTC pain reliever pills. So for my data analysis, first I found the standard deviation, then I created a bar graph and found the mean. I added error bars, and finally I ran a paired ANOVA test. So as you can see in this table, I got all my results as the same in all 5 trials for all of my before pHs, including the control group and my chemicals I used. So for the ibuprofen, as you can see, muriatic acid was less acidic, sodium bicarbonate was less alkaline, and water was more neutral. And this was the same for acetaminophen, ASA or acetylsalicylic acid, and naproxen. And as you can see, I included my ANOVA and bar graph charts. So this includes the dissolution time of my ibuprofen and acetaminophen. As you can see, the ibuprofen dissolved in all of the chemicals in no more than 10 minutes. And acetaminophen took a prolonged amount of time to dissolve in muriatic acid. This was the same outcome in the ASA. However, for naproxen, the naproxen did not dissolve in muriatic acid and sodium bicarbonate in the time limit at which I observed all of my OTC painkillers, which was 1 hour and 30 minutes. However, the interesting part was that water did dissolve the naproxen. So these are my line graphs for my dissolution time, and these are my ANOVA charts that I tested my accuracy with. In my conclusion, my hypothesis was partially supported because although the hydrochloric acid dissolved all the OTC painkillers at a slower pace than the sodium bicarbonate in water, which was a neutral fluid than sodium bicarbonate, dissolved all the OTC painkillers faster than the sodium bicarbonate, which was an alkaline fluid. A limitation in my experiment was visually identifying whether the OTC medicine fully dissolved within the chemicals. An obstacle was heating the chemicals to the right temperature, 37 degrees, and an assumption I made was that since naproxen was harder coated than the other OTC painkillers, it took a prolonged amount of time to dissolve in my chemicals because the other OTC painkillers were softer coated. In my future studies, I would add more chemicals modeling digestive enzymes and additional organ systems. I would reduce the interval at which I was measuring the pH from 10 minutes to 5 minutes, and I would add external additives to the chemical, like alcohol. Thank you for watching.